Hello everyone, welcome back to the video. In this video, we'll be solving the question maximum sum non-adjacent elements, right? So without wasting any time, let's look at the objective of the question. So if we take this over here, and if we read this out, it says that you are given a number n representing the count of elements, and then you are given n numbers representing the n elements, right? So we would be given n elements, and the third part, if we read that, it says that you are required to find the maximum sum of a subsequence with no adjacent elements, right? So you are required to find sum of elements such that none of those two elements are adjacent to each other, right? So if we take our input example from over here, if we take this sample input and output, and if we discuss about this, then what the question says is that if we have 6 elements, which are 5, 10, 10, 100, and then 5 and 6, right? Using these elements, what you have to generate is the maximum sum that you can do when you don't include the adjacent element, right? So if I'm including 5, in my sum, I cannot include 10, right? And similarly, let's suppose if I'm including my 100, I cannot include my 5. Neither I can include my 10, right? In that case. All right. So we have to maximize such sum, right? We have to make we can think of all the subsets in which there are no adjacent elements, and we have to maximize their sum, right? This is what the question says, right? So for this particular input, the output would be 116, and it would be using this 10, this 100, and then this 6. All of these could be added, and the total sum would be 116, right? Notice how we are not taking adjacent elements under consideration. If adjacent elements would have been allowed, of course, then the entire array would have been my answer, considering that the entire array has positive values, right? So if you think about it, even the constraint says that the values would vary from -1000 to +1000, right? So what you also have to consider is whether you have a negative value inside your array, right? So this is another constraint that you have to keep in mind. All right, so I hope you understood the question, right? And I would want you to try this on your own. And if you get stuck somewhere, then you should probably come back to this video, or you can also take the help of the article, right? So moving on with the solution of this question. Now we are going to solve this question using dynamic programming, of course. So before using dynamic programming, let's talk about the recursive approach, right? Let's talk about recursive approach. Again, for every element, what we are doing is we are making a subset, right? And we are considering the sum of that subset, right? So every element would have an option of either including itself in the subset or excluding itself in the subset, right? So the simple fund of inclusion and exclusion that we have been using up till now is something that we'll be utilizing in this question as well, right? So let's take example of the similar input, and let's reduce the input to 5, 10, 10, 100, and 5 again, right? So for my input 5, 10, 10, 100, and 5, if I draw the recursive tree, for this particular input, right? So very first level, let's suppose I am having choices for 5, right? So if my current summation, if I talk about my current summation, it would be 0, right? It would be 0, right? So if I include 5 or if I exclude 5, let's talk about this, right? So this entire level would be for 5, right? So I would write it over here. This level is for 5, right? If 5 includes itself, then my summation becomes 5, right? If 5 excludes itself, my summation remains to be 0. Let's denote it with blank, right? Then if my 5 blank with a 0, right? 5 includes itself and the summation is 5. So over here, I can write this is my subset, this is my sum, right? This is my subset and this is my sum. If I write it again, this is my subset, this is my sum, right? So 5 includes itself, that means it's the only element in the subset, then the sum becomes 5. If not, then my subset remains empty and the sum is 0, right? Again, what I would do is I would move on to next index. I have evaluated 5 over here. As I've evaluated 5, I would move on to next index, which is 100, right? Now, 10, right? So for 10, I would have again two options over here, include, exclude, and over here include and exclude, right? So if 10 includes itself, the subset would become 5 and 10, and the summation would be 15, of course, right? Now the question says that we cannot include two adjacent elements. So if I include 5 and if I include 10 again, this is a problem because we cannot have adjacent elements lying with each other, right? That means I cannot include 10 after I have included 5. If 5 has been included, the only option left over here for 10 is to exclude itself. So the call for inclusion won't be made, right? Because the question does not allow. So what would happen is 10 would exclude itself, 5 and 5. If 10 includes itself, 10 and 10. If 10 excludes itself, then empty subset and 0 again, right? Then again, if we choose for 10, right? If I take this entire array somewhere else, if I take this entire portion over here, if I remove the heading from here, have some space on top. So again, now for this 10, right? If it was excluded, if the previous 10 was excluded, then I can include or exclude myself. If the previous 10 was included, which was over here, I can only exclude myself. And if it was excluded, I can both include and exclude myself, right? So if I include myself, it would be 15, right? The summation would be 15 and I would have 5 and 10 over here, right? I remove this, right? And if I exclude myself, then again, it would be 5 with 5, right? Okay. If I exclude myself, then it would be 10, 10. If I include myself over here, it would be 10 and 10. And if I exclude, it would be empty and 0, right? Again, now I have evaluated both of my 10s, right? What I have to evaluate now is 100. So if I write for 100, if I write my 100 over here, then if I include my previous 10, then I can only exclude, right? So it remains the same, 5 and 10 with a total summation of 15. But if I have excluded myself, I can include, right? That means I can have what? I can have 105 with the summation of 105, right? I can include myself. I can also exclude myself. Then it would be what? It would be 5 and 5, right? Now in this case, as I had excluded myself, I can again include or exclude myself, right? If I include myself, it would be 110, right? The summation would be 110 with 110 as subsets, right? Then over here, if I exclude myself, I would have 10 and 10, right? I have included myself, then I can only exclude myself. That means 10 and 10, right? I've excluded myself, that means I can include and exclude both. So that means I can have 100 with a summation of 100 and 0 with a blank, right? So these are the total. If you see, these are my total subsets that are forming, right? Keeping in mind that I cannot have adjacent elements together, right? Out of all of these subsets, if we see the maximum summation is of this particular subset, right? That is, if I use my 110 to create a summation of 110, right? So if we see this on array, what we are doing is including these two elements. And these two elements would give me a total summation of 110. And this is the maximum summation that I can get, right? Okay, now that we know the recursive approach, we know that each element gets 2 of the choices, right? Either to include itself or exclude itself. Let's move on to DP quickly, right? Let's write DP and let's try to recognize how we are using this DP, right? This question is not even directly associated with DP, right? What it is more of a greedy approach. This question is more of a greedy approach. So what we are going to do is, if we look closely, what we are going to do is we are going to create maybe 2 variables, right? Or an array, right? Let's create an array, right? This array would have 2 sections. So we can either make 2 arrays or we can make a 1 array with 2 sections in it, right? 2D array. So let's, for sake of simplicity, create 2 arrays, right? Okay. My first array would be of inclusion. My second array would be of exclusion, right? And my size of array would be equivalent to the size of the input array, right? So in this case, the input array was of size 5, right? So what I can do is, across every index, I would write the element. So for 5, 10, 10, 100, and 5, right? This is the array that we have. Now, what we are going to do is define what this array means, like how we did in DP questions, right? So what does the array means is, at this particular point of time, right, I have to include 10. Every time I have to include 10, right? So at this particular point of time, out of these elements, what is the subset in which there is the maximum sum such that 10 is included, right? Again, if we think about this particular point, instead of this means that till here using 5, 10, 10, 100, what is the maximum sum that a subset could generate such that 100 is included? And this point would represent, again, what is the maximum sum a subset using all of these elements till 100 it can generate such that 100 is excluded from that subset, right? So 100 included, 100 excluded, right? Okay, so I undo this, right? Now, if you think about it, what would be the values in this case, in the very first case? When I'm talking about this particular element, there are only two possible subsets, empty or a subset that has 5 in it, right? So if 5 includes itself, then it would be this subset. If 5 excludes itself, it would be this subset, right? So the sum over here, if I include myself, would be 5, right? If I write this with green pen, right? Okay, yeah. So it would be 5. If I exclude myself, that means I'm not joining an empty subset, so the exclusion would be 0. Now, if you think about 10, if you think about this, if I have to include myself, I can only include myself if my previous element has excluded itself, because we don't want adjacent elements in the subset, right? So it's mandatory for the element that is next to me, that was my previous element, it had to be excluded, right? So the subset had to exclude 5 in order to include 10. That means I would take this and include myself in it, right? So 0 plus 10 would give me 10, right? Now, if 10 is excluded, that means my previous element could either be in the subset or it cannot be in the subset. It's the choice, right? It's the choice. Now, if there is a choice, what we have to do is we have to consider the maximum out of these two, right? We have to consider maximum out of these two. Okay, so what we would do is the maximum out of these two is 5, right? Now, if we move forward, if 10 wants to be included, then the previous 10 had to be excluded, right? So the sum would be 15 over here, and maximum of these two 10, right? If we run forward, we have 100 over here. If we want to include it, it would be 110. If we want to exclude it, it would be maximum of these two, which is 15, right? 15. If you want to include 5, we would add 5 to 15, right? So we would get 20 over here, and maximum of these two, which would be 110, right? Now, if we look closely and if we observe this particular part, the last position, what does my last position signify, right? The maximum sum that I could generate with the subset such that all of my elements were utilized. This is what our question was, right? Our question was the same, right? Maximum sum of non-adjacent elements, right? So out of these two, whichever is the maximum would be my answer. And out of these two, as 110 is the maximum, this would be my answer, right? And if we come back over here to our recursive approach, we can see that we also had 110 as answer using our recursion, right? This greedy approach is working. If you observe over here, only because when we have excluded ourselves, when we are excluding ourselves, after that we have two choices, right? If we want to exclude ourselves, there are two choices in which I can exclude myself. I can exclude myself either when the previous state is excluded, or I can exclude myself if the previous state is included, right? So if we look closely, the total call of this is nothing but similar to the call of this, right? The only difference is this sum, this entire tree would be always 5 ahead of this tree. That is because we included 5 in this case, right? So out of these two, whichever was maximum at this point, right, would win, right? So our answer would be not from this point. And this is what we discard, right? When we are taking maximum out of previous two states, to exclude ourselves, then we are ignoring the other state, right? If we are taking maximum over here as 5, we are excluding the state where 5 was excluded, right? Over here, if we look at this, when we are taking maximum out of 15 and 10, and we take 15 over here, we are excluding the point where 10 had excluded itself, right? This was ignored, right? This is because our maximum would always be greater than this ignored call, right? And this is why this is a greedy approach, right? We are going towards answers that are sure to give us maximum benefits, right? So if we come back over here again, if we see, if I had to include something, let's suppose here and here, then I had only one option. My previous has to be excluded, right? And that is why over here, if we see, when I have to include myself, I always look at just the exclusion part, right? Exclusion state over here to exclusion state, right? I hope this is clear. I hope you got how we approach this greedy problem, and I hope how the traversal is happening is clear to you, right? Now, what we are interested in is how we can program this. We can either take inclusion and exclusion array that we have taken right now as of the size of the original array that we have been provided with, or what we can also do is much smarter way to do this is that we can just take two variables. Now, if you look closely at any particular point of time, what we want are just two values of previous state, right? We want just two values of inclusion and exclusion of previous state. So there is no need for us to take an entire array. What we can do is we can just create two inclusion and exclusion states, and using those we can proceed forward, right? So if we had to code this, what we could do is first of all create a scanner to take inputs. So scanner system.in n is equal to sc.nextInt, and then we have an array, right, of size n, and then we have to take its input, right? So int I is equal to 0, I goes to n, I plus plus, right? ARR of I is equal to sc.nextInt. Okay. Now, what we have to do is, of course, take two variables, right? So one variable would be inclusion, and there would be some value over here. Let's see what, and one value would be exclusion, and there would be some value over here. Now, what we have to write over here instead of question mark are our base cases, right? So if you remember, what was our base case? Our base case were for the 0th position, the very first state, right? For the very first element. The very first element can either include itself or exclude itself, of course. And if it excludes itself, we would get an empty subset because it's the very first element, and the sum of that empty subset would be 0. So we know that at exclusion, we would have 0 over here. But if you think of inclusion, right, over here we had 5. So if 5 include itself, what we would get is a subset of 5, and the sum would be 5, right? So it's easy. We can write the value of the very first element as inclusion. But this would fail if I had the first element as -5, right? If I include myself as -5, I would have my summation as -5, right? But this is not the maximum. What we want is the maximum. So if my value is negative, there is no benefit for me to include it in my sum, right? So if there is no possibility for me to include myself, then what I would do is, if I have a negative value, I would just write 0 over there, right? I hope this is clear, because we are interested in maximizing our sum. If we get any negative value, we would just add 0 instead of it, right? Because negative value would then propagate and reduce our sum. So what we can do is we can check over here, if my array of 0, if it is smaller than 0, right? If it is smaller than 0, that means it's negative, right? What we can do is we can have 0. Otherwise, we can simply have an array of 0 over here, right? Now, what do we have to do from the second index, right? From the second index, which is our first index, second element, which is our first index, right? So we have to traverse till the last index, which is n. Right now, what do we have to do? We have to create new inclusion and exclusion states, right? So new inclusion state. What would be my new inclusion state? I can only include myself after I excluded myself. So I can exclude myself and have I can include array of I over here, right? And what would be my new exclusion state? This would be max of my inclusion state and exclusion state, right? And over here we would ignore one case, right? Now inclusion would be new inclusion and exclusion would be new exclusion, right? And at the end of this, after this traversal, what we would have is our answer would be the maximum math.max of the inclusion as well as exclusion, right? And if we take this in full screen and if we print this, system.out.println here, we print the answer, then we should get this correct, right? So let's run this. So we are getting compilation error. That is because we have not used new over here. So let's write that. Let's run this again. Okay, so it's passing our test case. Let's submit it for all the test cases, right? Right, so it's running for all the test cases. So I hope you understood how we approach this problem, right? We basically use the principle of, again, inclusion and exclusion, which we have done a multiple number of times in previous questions as well. Then what we did was we maximized both of those states, right? We maximized both of those states and we ignored basically the part of tree where I would get minimal answer, right? I always gave preference to the tree where I would get my maximum answer for. And this is what is greedy problem, right? This is the greedy approach. We only give preference to the part, the solution where I would get maximum benefit, right? This is my greedy approach. And at the end, I had my answer in inclusion and exclusion maximum, right? So I hope you understood this. The last thing that I want to discuss about this question is the time complexity. So as you can see over here, what we took was just 2 variables to solve this question. So the space complexity, if we talk about it, is constant, right? And the time complexity, if you see, we reduced it. Okay, so very first we discussed the recursive approach, which had the time complexity of 2 raised to power n. But now we have reduced the time complexity to O of n, right? A single for loop is doing the job for us. So we have the time and space complexity like these. Okay, so I hope you understood this video. Please share it with your friends if you did. I will see you in the next video. Bye bye.